All right, we're looking into example 2, and this is looking into evaluating functions. And this is we're actually going to be not looking at the domain of the functions this time, but the algebra of the functions. Okay, so for the first example, or for these three problems, A, B, and C, we're going to be plugging numbers into different algebras of functions involving addition, multiplication, and division. Let's look at these. So first off, we have f plus g of 5. So the best way to organize this, I'll show you the best way I like to organize this. And it's just pretty much using the definition at first. And the definition is addressed in the previous slide. But we know that f plus g, we can separate it like this. F of 5 plus g of 5, separating it into two separate functions, and now we can look at each individual function. So now we have f of 5, which that means we're going to plug in 5 in for x into the function f, and that gives us 5 squared minus 9. And then we're going to add g of 5. Okay, so we're going to plug 5 into g, and we get 2 times 5 plus 6. And you'll notice that I put parentheses around what was f of 5 and g of 5 after substituting. They're not actually doing anything. The addition, it's not really necessary. You'll notice it's more important when you're dealing with multiplication. So, and subtraction. Subtraction multiplication is where it really comes in. It's really necessary. So let's look at this now. And simplify. So we don't actually need these parentheses, but let's simplify. We have 25 minus 9 plus 2 times 5 is 10 plus 6. We can simplify that left to right. Let's go 25 minus 9, and that is 16. And then we're going to add 10 plus 6. 16 plus 10 plus 6, since they're all addition, we'll just do it at one time. 26 and then 32. Okay, so we have the result. Now let's look at B. Okay, so for B, we're looking at f of g of negative 1. Similarly to addition, the first step, you just apply the algebra function definition, and for multiplication, we can separate it like this. Again, in the previous slide, it shows this breakdown for the first step using x, but we have negative 1 here. Okay, and now we can substitute negative 1 into each individual function, and that gives us negative 1 squared minus 9. And as I mentioned before, you need the parentheses here, and I'll explain that in a moment. G of negative 1. G of negative 1, we plug in negative 1, we have 2 times negative 1 plus 6. Okay, so notice that if we did not put the parentheses here, we want to make sure we multiply all of f of negative 1 by all of g of negative 1. That's what it's saying up here. But if we didn't put parentheses around, then only the negative 9 would be multiplying by the 2. We want all of this to multiply by all of this, and that's what the parentheses is saying. And so let's go ahead and simplify at this point. And that would give us negative 1 squared is 1, then minus 9, times 2 times negative 1 is negative 2, plus 6. I'll just write that down. 1 minus 9 is negative 8, times negative 2 plus 6 is 4. Negative 8 times 4 is negative 32. And then the last problem we'll do now, and that is f divided g of 4. Okay, so here we want to apply the property, and f of for algebra functions, f of 4 and g of 4. We're going to be dividing. We can look at these individually as before, similar to before. And we have f of 4 is 4 squared minus 9. And g of 4, we're dividing, g of 4 is 2 times 4 plus 6. 4 squared is 16 minus 9 is 7. 16, yeah, 7. And 2 times 4 is 8 plus 6 is 14. So we have 1/2. All right, hopefully that makes sense. Let me know if you have any concerns about the algebra functions, of evaluating problems involving algebra functions, and I'll be more than happy to help.